Now we're going to take a look at circle theorems. So before we start going through all the different circle theorems, it's really important you know what to look for in the basics. Okay, so when a line goes from one point on the circumference to another, we call that a chord. This is a chord, like guitar strings going across the hole in the middle. We have a special chord that goes through the center. I'm just going to rotate my paper a little bit. So again, it's going from one point to the other, but because it goes through the middle, you should all know that's called the diameter. And if it comes from the middle to the circumference, so basically half of the diameter, that's called a radius. And if we have a line that just touches the circumference, the outside of the circle, this is called a tangent. They're the two words that you might be less familiar with. But as long as you know that, all circle theorems you should be able to spot relatively easily. If you've got to basically remember these, unfortunately. So the first three I'm going to talk to you about are ones with tangents. So if there's a tangent, I'm going to try and get into your brain what to look for. If there's a chord, I'm going to tell you what to look for. If there's a radius, I'm going to tell you what to look for. So the first thing that they really use a lot is this. If there is a tangent and a radius, they always meet at 90. And nowadays you have to explain what it is you see. So you have to say that this angle is 90 because a tangent and a radius always meet at 90. So that's quite easy. Now, I like to call it the ultimate circle theorem. It's called alternate segment theorem. I'll just write that down. So it's alternate segment theorem. And I haven't told you what a segment is, but I'll quickly do that now. So if you have a tangent and a chord, so this time not a radius, but a chord. This is called a segment, and this is also called a segment, like a minor and a major segments. But from this chord, if you have another chord, and then joining back with another chord to that initial point, so therefore making a triangle, what you actually have is an angle between the chord and the tangent. I'm going to colour that in. And it's actually always equal to the one opposite. So these two are equal. But because we have a chord this side and a tangent, we also have another angle here. I'm going to do this one with a double line. And therefore it's equal to this one, opposite. So alternate segment theorem, if you know that one, you know this one. Or if you know this one, you know that one. And vice versa. And the last one, if you have a tangent from a point and then you have another tangent from that same point, what it actually creates is this. The length here and here are always the same. Now that one comes very handy when we combine it with this one, which is the radius one, because actually what you're forming is a kite, because those two are the same and those two are the same, and therefore you can apply properties of a kite or any quadrilateral really. So that's what to look for if you have tangents. Now if you have a chord and you do another chord, just like we did with the alternate segment theorem, and then we go back down, I'm deliberately trying to miss the center point here. So I've gone up to the circumference and back down. And if I do that again, so just making lots of different triangles, I'm going to just colour this one in thickly so you can see where I'm going from. I could do this loads of times. So I can come over here. So just up and down, make sure you're going from both ends. What it actually means is every single one of these angles will be the same. So when we're describing this, we say the angles from the same chord. So angles from the same chord are equal. These are all the same as each other. Okay, so angles from the same chord. Now they can be a bit tricky in the exam, because what they can do this. So the chord isn't there, but there could be a chord there, and there also could be a chord here. So if your chord was there, it would mean these two are the same, and feel free to draw it in on your exam paper. I'll just do this one in the dotted line. If the chord was there, imagine going the triangles upside down, it would mean these two would be the same. So they try and hide this by hiding the chord to be ready for it. This one, if you have a chord, but this time instead of making a triangle, you make a four-sided shape, a quadrilateral. We call it a cyclic quadrilateral. And in this, you have the opposites, but they're not the same. They add up to 180. So these ones add up to 180. So if this one was 100, I was going to add something else, but I chose not to. This one would be 80. They must add up. And that's the same for these two. These two also add up to 180. And if you have the special chord, i.e. the diameter, and you make a triangle, this always creates a 90-degree angle. So I like to call this one angles in a semicircle. So when I'm describing this, I just say angles in a semicircle, always 90, because by a diameter you're creating a semicircle. Or you can say the angle from a diameter is 90, something along those lines. Nearly there. The last one, and this can be quite often tricky, is if you have a radius. Now, if you have a radius, you'll always, well, I say always, most of the time, have another radius. So if I join these up, you should be able to see that that would make an isosceles triangle. We often use that. But if we then combine these with chords like this, one chord and another chord, there's a very special pattern between these numbers. So if this was x, for example, this one is always double it. So if this was 140, this would be 70. If this was 30, this would be 60. That always happens. But this one is very, very mischievous. I'll show you why. So what we can do is we can do this. So there's a chord and there's a chord. It no longer looks like that. But if you can imagine bringing that round, it is the same. So it means if that's x, this one is 2x. And they can be even more naughty with it, really. Is start again with those, but instead of going up, we can come down, so that's still a chord, and it looks a lot like this one. But here, the chord, these are chords, each one's on the circumference. These are chords, but these are radius or radii, so it's not this theorem. This has all 4 chords, this only has 2. But again, if you can imagine that point there, round here, it's this. So if you look carefully at this one, if you go past the centre, that angle is always double. So this one, when you go past the centre, if it was up here, this is double. So if I know this one, it's this bit that's actually the 2x. It's very, very, very tricky, and they often catch you out with that one. So let's have a look at some questions. So here, we're just going to try and fill up loads of angles. So I can see I've got a point, 2 radius, so I know they're the same, which means that this is an isosceles triangle. So if that's 70, I must have 110 left over, so therefore that must be 55, and that must be 55. Now, I have radius, 2 radius with my tangents, so I know that must be 90, and I know that must be 90. And because I've got this as 90 and that's 55, I can now tell you that these are 35. And because I've got 2 radius, that means I have an isosceles triangle, which also means they have to be the same. So that's 70. That means in this triangle, that must be, I'm going to have to put it over here, 110. And if you look, you've got your kite. So on a kite, these always add up to 180, and these have to be the same. There we go. Right, from here, if I know this one, I've got 2 radii and 2 chords, so it's the one I've just spoken about. So this has to be half of that. So this has to be 55. So the angle at the circumference is always half the one at the centre. So, loads of angles filled up on there. Let's have a look at this one. I've got a specific question here, so I'm telling you that's 60. So I have a tangent and a chord. From that chord, I've made a triangle. So this is the alternate segment theorem. So that's also 60. I can see here I've got a triangle. So if that's 60 and that's 40, that makes 100. That therefore has to be 80. 180 degrees in a triangle. And 4 chords making a quadrilateral inside, called a cyclic quadrilateral. So if that's 80, that has to be 100. So it's learning the theorems. Now here's a really tricky one. So here I'm trying to trick you with the 2 radii and 2 chords. So I've got my 2 radii and from them I've got a chord. So if that's 120, that has to be 60, if you can imagine dragging that point round here. So what I'm going to quickly do is just pencil that in. So if that was 60, I now have a cyclic quadrilateral. That's 100. Sorry, that's 60. So this one must be 120.